So hello everyone, today we were working on some practice runs on 15 and 16, as you can see, but we didn't get enough time to finish all of the practice runs that I prepared for you guys, and I know that for some of them you guys got really confused and maybe a little bit scared because it's not the format that you guys are used to it, and it's okay. You guys can be confused, you can be scared right now, so hopefully we can resolve that right now. But yeah, so just before we do the awful mechanisms and all of that, just a quick little notice and shout out to my dogs and my cat. So that's from Halloween. So hopefully that's gonna make you a little bit happy. If not, that's okay. Let's just get on with the problems. Okay, so I'm just gonna be walking through the chapter 16 portion because chapter 15 was pretty much okay. But once we got to the questions on your acetals, your ketols, those guys, that's when we started freaking out a little bit. Now, we know that our basic shortcut is just or decapitation, right? We chop off the head. And then usually we're just used to one R group and one alcohol group. But this time something different, a diol is provided. Now, it's the same reaction. It looks slightly different. And practically whenever you see any alcohol groups, any diols that are part of the same molecule, that should point you out to an intermolecular reaction. So you're always going to end up with some sort of cyclic structure over here. Now, we know specifically we're creating the cyclic structure because we want to achieve the acetal. Since an acid is given, remember, acids, those guys can proceed to the full form, okay? If we had a base, then we would have to stop at the hemi form. Now, quick shortcut, we talked about it in the side, so you guys can check out the recording for that one. But quickly, chop off the head. We know that we're going to keep the legs. That's what we did over here. And then we grow two arms instead of a head. And we know that in those arms we have oxygens. Now, because I know that I have to create an acetal, I have to add an R group on both sides of the oxygen. More specifically, it's the carbon chain that you see in here. Okay, so for the mechanism, don't freak out. It's gonna end up with a little funky product that you guys are not used to it, but still, it follows the same criteria that we did for the shortcuts. Legs, acetal, it came from an aldehyde, so R group and hydrogen. In the arms, we have two OR groups, and that's it. But for the mechanism, pretty much we know that acids, remember, you have to know this portion of the mechanism. You have to know what acids and bases do. Acids, they just make the electrophile more electrophilic. So that's why either of those oxygens is going to be attacking our acid. So we can gain a positive charge over here. So now our electrophile, it's perfect. We see the positive charge. We're good to proceed. So once we have this guy ready, now we can continue with the reaction. So this guy over here is going to come back. So either of those oxygens again does the nucleophilic attack, and remember, to not break the oxide, I have to push up the electrons to the oxygen. So that's why now we have this tetrahedral intermediate. We basically went from something that's sp2 to something that's sp3. Now, at this point, we have an oxygen with a positive charge. That oxygen is not so happy. So remember that we were presented with an acid and we used it in the very first step. That means that we're creating the conjugate base of that acid. So in this case, to just generalize it, I just wrote an A minus. That just represents the conjugate base. But pretty much, it's just going to neutralize our product in here. So far, we create the hemiacetal. Remember, the hemiacetal is always going to be one of the intermediates before you achieve the acetal. Same process with a keto. Hemiketo, intermediate before you reach the keto. Now, because we have an acid, we're going to keep going with the reaction. So our oxygen here is going to be taking away the hydrogen from the oxygen that was part of the reagent, actually. This one over here. So once we do that, we create a pretty good leading group. And now we have a pretty good nucleophile. So nucleophilic attack, that means that we're making a new connection and then we kick out water so we don't break the octet. And that's it. Simple as that. Now for this one, it looked a little bit scarier because everything was practically within the same molecule. Now, in this case, let's just look at what we have in the molecule. We are starting with an aldehyde, okay? And we have an alcohol group. So aldehyde, alcohol, I can create two things, hemiacetal or acetal. I'm given an acid in this case, so we're expecting to create an acetal. Now, in this case, you have to be a little bit more careful. And this is one of the very few problems in where you should actually try the mechanism because we're not going to end up with the predicted acetal. Because at the end, we actually end up with the hemiacetal, even though we have an acid. But let's see why that's the case. So in this case, we know very first step, acid, it makes the electrophile more electrophilic. That's why that oxygen has a positive charge now. Now, oxygen from the alcohol group, nucleophilic attack, that carbon, which means that it gets connected in here. You kick up the electron so you don't break that 4-octet. So that's when you start forming the cyclic structure. Okay, and it's actually color-coded for you guys to follow. The new bond that we just made for the nucleophilic attack, it's over here. Okay, and then the rest of the bonds that you see in here, they came from the initial molecule. Now, we have a positive charge. We don't like that. So like we saw in the previous example, our conjugate base that was formed in the very first step comes back, takes away that hydrogen, and everything is neutral now. Now, in this case, because we don't have any more moles of our aldehyde, we can proceed with the reaction again. Plus, sorry, it wasn't the aldehyde, it was the alcohol group. We're only given with 1 mole of the initial molecule, which contains that reagent that we need. So we only have 1 available, so we cannot proceed with the next step to create the full acetal. Okay, so that's the reason why we're stopping at the hemi form in this case. Okay, now see, this is where we stopped in the side. But again, this one looks somewhat similar to the first example, example A. So that guy presented the ketone or aldehyde, I don't remember, over here first. And the reagent, the diol, was presented over the arrow. Sometimes they can be switched, but again, it's the same exact reaction. So just, you have to identify that grouping specifically of reagents. Now, we have our ketone plus an acid, and we are reacting with alcohol. So I know that I'm creating a keto or a hemiketo, but specifically because of the acid, I'm going all the way to the keto form. So very first step, we just protonate our oxygen in there. We have a pretty good electrophile. Either of those oxygens is just going to do the nucleophilic attack, get connected in there, and then we have to kick up the electrons towards the oxygen so we don't break the octet. So at this point, we have this little monster in here. Okay, so we have practically the hemiketo. Remember, hemiketo, the legs, those guys are from your ketone, it's just R groups. And then the arms, they're not symmetrical to each other. One of them has an alcohol group, the other one has an OR group, which is what we have in there. And actually, let me just write it for you guys so you can have it in the answer key. Okay, now, at this point, similar process to what we saw before. So this oxygen is gonna grab one of those hydrogens. So we can make it into, sorry, that should be backwards. That's on me. Okay, so at this point, don't look at the other stuff. Just focus on this portion. So we want to make this guy into our leading group. Why? Because remember, to get the keto form, my 2 arms in here have to be symmetrical to each other. I need 2 OR groups. So I need to get rid of that OH. So let's see how that's going to happen. Oops. Okay, so to make it a good leaving group, I need to mix something that's more happier on its own. So this oxygen is gonna be getting that hydrogen. So now we're creating water, which should be on this step. Let's ignore this. Do not look at that. Okay, there we go. So we have that structure. And actually let me redraw it for you guys. Okay, so this is the structure that we have. And then after that acid-base reaction, we know that this oxygen here is gaining an extra hydrogen. So now it has a positive charge. So it's a good leaving group. Now we're ready to form the acetal, sorry, the keto. So now that oxygen does the nucleophilic attack, which means that it gets connected in there. And actually, let's do it with red since it's already in the product. So nucleophilic attack, it gets connected there, and then kick out your water so you don't break the octet. So that's how you end up forming your actual product. Okay. Hopefully that clarifies some of the questions that we had during SI. And don't worry, like this will answer key. It's already posted on their file, so you can check it out, download it, anything you want. Now, this is a problem that we didn't get to because of time, but this is practically a multi-step synthesis that's throwing some concepts from chapter 12, which is your theory epoxides. Hopefully you didn't forget about those guys. Not yet. You still have to remember the final is cumulative. So if you haven't started your list of reagents, I would start that right now. Okay, so in this case, we're starting with a little epoxide that has an acid cleavage. We know that the ranking for that guy, it's tertiary, then primary, and then secondary. Remember, this is for Dr. West. If you're taking Dr. Roche, then it's 3, 2, 1. So we look at our carbons in here. We have the tertiary one, so we're going to be cleaving that one. And then we cleave, and technically on the tertiary carbon, because that one lost a bond, that's where the carbocation goes. But I'm provided with water. So water is going to be attacking that carbocation. And that's why we end up with a molecule that has 2 OHs. Now, we have this structure, and the next reagent is aldehyde with an acid. Aldehyde. I can create 2 things, again, hemiacetal or acetal. Specifically, we have an acid. So we're going all the way to the full form. So we're creating an acetal. Okay, so very first step, we know that we have to make the electrophile or electrophilic. That's why this oxygen now, the carbonyl has a positive charge. Now, after we have that guy, now we can proceed with a normal reaction. So either of those oxygens is going to do the attack. It doesn't really matter. I think that it would attack, this one would attack first because it's less directly in there, but at the end, no matter which one attacks, you're going to end up with the same exact product. Either way, it's going to do the nucleophilic attack, which means it gets connected to this carbon, and you have to kick up the electron so you don't break the Bohr octet in that carbon. So you're ending up with this little guy in here. Remember, this oxygen, that was from the carbonyl, which has a hydrogen in here. And right now is not so happy because it has a positive charge. It has 3 bonds, so we have to fix that. So in this case, we're going to do a little intermolecular acid-base reaction in which the oxygen of the hemiacetal, let me write it down for you actually. Of that hemiacetal, this guy is going to take away that hydrogen. Why? Because remember, the goal is to create the acetal, so we need symmetrical arms. So I need to get rid of that OH, so I can add another OR group. So now we have water. This oxygen is neutral, it's happy. So now Again, nucleophilic attack with the other oxygen that was forming the diol. It gets connected here, and we have to kick out water so we don't break the poor octet. So that's how we end up with this guy. So I know that we didn't have time to go through that problem, but if you have any questions about it that weren't answered in this video, just send me an email and I'll respond as quickly as possible. Now, the other one, I wanted to do retrosynthesis. Now, in this case, you were provided with an enamine. So this is the memorization part that I told you guys that you have to remember. Amines, enamines, hydrazone, oximes. You have to know how those guys look like, and you have to know the names of the reagents. Hydroxylamine, hydrazine, primary amine, things like that. And that's all in the spiderweb that was provided in the essay session before. Now, for this case, this one should be pretty simple, but we know that our nitrogen in our enemies that's usually coming from our reagent. Okay, that's the new head that we have. So I know that that carbon chain is still connected to the nitrogen. And then to make everything neutral, I have to add a little hydrogen there. Why? Because remember, for enemies, we need a secondary amine for the reagent. And now in this case, we just have a pure carbon chain. So that means that instead of starting with an aldehyde, we start with a ketone. Specifically, it's this guy. Okay. And that's pretty much it. So I know that I gave you a lot of hard problems, so don't stress too much about them. It's just to make you practice every single thing that we went through in the past essay sessions. Now, most likely, you're just gonna get one of these problems, possibly just example A. But still, it's good to know the mechanism for questions like these because we can predict the product, but this was a special example. So with the mechanism, you can follow around and see if it's actually possible to form that guy that you're expecting. But either way, I know it's a lot, so take your time. I know that a lot of you guys are having a lot of exams this week. So best of luck in those and try not to stress too much about it. I know that it's hard. Trust me, I've been in your place, but again, try to calm down, take it step by step, day by day. And then here's a little motivation for you guys. Okay. So just keep working. It's okay if you ever need to talk about anything in the class, or maybe if you just want to vent, I'm here for you. I'll try to help you as best as I can. So remember, you're not alone in this.